So our first speaker today is Noel Dunlop. Noel's career has been dedicated to the energy, chemical and industrial sectors for more than 20 years. During this time, he has successfully developed and driven a number of new companies, commercial programs and products with a strong focus on chemicals, energy systems and technology development. For the past decade, Noel has contributed to the emergence of renewable hydrogen as an energy solution through the founding of Energies Australia. Please welcome Noel for his presentation titled Australia's Relevance to a Global Hydrogen Marketplace.
From yesterday was a green button, wasn't it? Yep, that's working. Thank you. I suppose I need to stand close to this. Yeah, good. Okay. I've just got a rough agenda of what I'm going to go through. So when going through and being asked to speak, it was sort of to look at Australia's relevance to the global hydrogen markets and what we're going to do both here and overseas. So I'll go through a little bit of what's actually happening, a little bit about who we are as Energists and what we're trying to do and what we have done, what's happening in Australia right now, try to cut through the noise. So we heard lots yesterday about some exciting things that might happen, but I'll try to carry what's actually happening in that one, and some examples of what we've actually done as well to help some of those projects. And then the future of hydrogen in Australia, and we sort of started to hear some of that yesterday as well. So some of it might be a recap, but to think about what can we do right now and going on from what you just said then, about what is going to happen in the next year or 2 or 3 years, rather than what's going to happen post 28, 2030, when we actually get some of these things happening. Relevance. So over the last 8 or so years, you see all these wonderful things come out in Australia. Starting back from the South Australian strategy, and that's came out in 2016-17. And Vizian helped write that, and along with the working group, which we were part of. The South Australian Action Plan, which is up there, was actually then after the election when they changed government, and the Liberal government rebranded it, made it a nice blue folder rather than a red folder, and it became the Action Plan, but not much different really than the actual original strategy. And then we had all the other roadmaps, the National CSI Roadmap, which came out. The COAG then went from that, and the National Strategy came out. Why I'm putting all these up, though, is we actually do have government willing to support it. And this is a very, very far cry from when I first started this company. When I went to my VC mates, when I came back from overseas, I got some hydrogen technology. I think it might have a place in the Australian market and overseas. And they laughed at me and said, no one's going to give you money. No one. So we went back and we looked at how we could do it differently. But going through the agenda in post-2018 to right now, 2022, there is strong government support and willingness to try to help. And I'll go through some of those things about what they're trying to do right now. And so this is taken from Allen's. This is not Energist, this is Allen's Consulting. So I'll reference what they did, but they're talking about where they've set targets and what they're trying to do and where they're trying to help. So the federal government, we've got targets set for 2030, which is in line with some of the larger things we heard from FFI yesterday and where they want to start to try to get exports, because the federal government's more about exports and trying to grow and stay an energy supplier to the world. New South Wales have set targets for 2030 and goes through. Victoria, 2026, we're reviews every 5 years. WA, because part of that working group, and they've got some projects up and running they've been funding and trying to get up and running. So Denham was one of those that they helped support with Arena, and they've got long-term targets to 2030. But if you look at all through, and Northern Territory, they sort of have some plans, they're rehashing it, they'll come out soon again. But they are getting there. The point is that we do have strong willingness to try to get something to happen. And that's the difference between what I'm probably trying to work on now is we have a willingness to something to happen, but are we going to do stuff? Because it is a global race. You look at all these things, and I can go through and, we heard numbers of $56 billion of projects potentially going to work over the world over the next 5 years. How many of them are actually going to be in Australia? How many of them are actually going to hit the ground and actually do stuff? Because there's lots of talk about feasibility studies going to FEED, which is the final engineering to enable an investment decision to be made. What's actually going to be done and how are we going to play a role in it? leadership. The governments talk about we want to be the hydrogen leaders, we want to be global players, we want to have significance in the market. We do have some advantages. We have advantages that we've got really, really good renewables, and Evan spoke about some of this in the similar graph that he had around the wind and where they're located. Solar right through the middle, you can see great irradiance, where we can have longer solar for longer periods of time, more economical than some of the other places in the world. But we still are competing against Portugal, Spain, Middle East, who have similar sorts of benefits. So it is a race, and they're putting billions of dollars towards it. Not millions, billions. You know, Germany came out, put $6 billion towards hydrogen over the next 10 years to help their companies develop technologies to export, as well as to bring hydrogen back to them. France came out with €7 billion. European Union came out with €4 billion on top of it. UK came out with £6 billion towards driving their companies to help develop local industry. We're not supporting local manufacturing in that way. Not yet. But we do have some really good things. We're uniquely placed in terms of energy supply around us, and we talked about microgrids and how we do that. We've got the world's largest swirl lines, and power electronics will know what I mean by a swirl line: single wire earth return. That's one wire going nowhere. And it's great if you're the first house on the line, because you get the power. Then you get voltage drop. You're the second house, you got a little bit of power. By the time you get to the 10th house, an idea of those lines was there was a light and a fridge that they kept running normally. Now there's air conditions, lights, videos, computers. So by the time you get to your house, bad luck. And so what most people are doing is saying it's too expensive to build swirl lines. We need standalone power systems. So standalone power systems are solar, battery, diesel. And therefore, those people at the end of the lines, that it's too expensive to build a line to you, it's cheaper to put that system in. The Western Australian government came out and said by 2025, and it was said yesterday by Horizon Power, they can't put diesel systems in there anymore. The only real solution is a hydrogen-based solution in conjunction with the solar battery. And they work, and they work now. Rail, road, and marine. We have much further distances to travel than most of the other places around the world to go from place to place. Tassie is ideally located to only have 2 or 3 key refueling, and they could almost replace their trucks right now. And the other one, which is what the federal government's really interested in, remain a global player in energy exports. Coal's got to be displaced between now and 2035, 2040 at the latest. It still will play a role going forward, much smaller role though. Gas, and I'll talk about some other gas things that are occurring, will be transitioning, and even our own gas industry talk about what's happening in the gas world. By 2050, they want renewable hydrogen, like green hydrogen, blue hydrogen, or biogas going through the gas lines. So, why do we have some sort of comments on why I get to stand up today? We're a green hydrogen company started 10 years ago when VC said, no, you're a dumb idea. We're privately owned still. We provide products and solutions for fuel hydrogen cycles. So we've got systems from refueling right through to product and energies and hydrogen production systems, which I'll go through in a little bit. We've got proven real-world applications already in the market, and so that's really important to us. We don't want to try to get up and say we're going to put an MOU in place or we've got a weather station on something. We're about delivering solutions now. We've actually managed to grow over COVID from a team of 12 where we restructured at the start of COVID to a team of 35. We've moved into a new manufacturing facility in Mulgrave in Melbourne, which is dedicated to us, which allows us to put our own hydrogen testing system back in, allows us to do a lot of things we couldn't do when we were sharing a facility. We've got a new hydrogen production facility, which I'll talk about, one of the current projects. And we've got major contracts in Australia and for exports as well. When we restructured, we sort of finalised and said, well, what are our core business systems that we want to try to focus on? Fuel cell applications, and we've got a lot of work in that area. We've been doing integration of fuel cell modules, and that includes, the best way I can describe it is a fuel cell module is a really cool thing, but it's basically an engine block. Unless you put all the wonderful things which Evan mentioned yesterday around that engine block, you can't drive the thing. It doesn't do anything. So we've got unique skills in actually doing that, and it's allowed us to win jobs both here and overseas. Green hydrogen supply, and that's really because we want our products to start going out the door. And one of the criterion pinch points that we were talking about yesterday is, where do I get my green hydrogen from? would love to use one of your products, but where do we get the green hydrogen? So selfishly, we've gone and developed our own green hydrogen sites to make that happen. And consulting, and that was mainly because we started that way. It was about educating the market, educating the governments, and we needed to start saying we need to get some revenue from this. We just can't do this free of education. And so we do boutique consulting through collaborations internationally and with clients to help provide hydrogen-based solutions. So we've done projects in Oman, Middle East, South America, UK, Spain, where we've looked and developed hydrogen solutions at concept to feed level with international partners. What's actually happening in Australia? Hopefully I won't be too controversial and won't leave people out, and if I do, I apologise, because there's a lot of things happening right now, but this is trying to break it down to what's already on the ground, and that was spoken about, some of the things that are actually already there. Gas vision, which I talked about, the 2050 gas vision. This was done independent of the government. So this came out about 4 or 5 years ago, the 2050 gas vision. They want to put green hydrogen, blue hydrogen, and renewable methane or biomethane through the gas lines by 2050 to decarbonise the gas in Australia. That was a group of gas companies all getting together and saying, this is what we want to do for the environment and for the betterment of the country. So blending steps, Germany, Canada, Leeds have all been doing this for a long time. Germany already had a target 5 years ago for 12% and had a project running. There's a project doing this already in Canada where they actually take excess renewables from the grid. So they act as a grid firming electrolyzer. It's a 5 megawatt system. They take that hydrogen and it goes directly back into the grid as grid support. And it's economical. And I understand what Jared was saying yesterday from Gemini, because we help with that project. But it's economical because they get paid $2 million a year for grid support. So the hydrogen's cheap. The $2 million a year for grid support, which allows more renewables to go onto the grid and they can balance the grid load, they get paid for that service. So that covers the cost of the capital of setting the system up over 5-10 years. Hydrogen's almost nothing, it's just the operational cost. So they can get $1 a kilogram hydrogen into the gas line and it's viable. But we have to think about how we do things, and it's not a simple problem. It's a complex problem that needs a complex solution, and not one silver bullet will fix all. Australia trials underway, Jandakot and WA, so ATCO. AGIG have got Hype's SA up and running. It's still the biggest electrolyser still currently running in Australia, 1.25 megawatt Siemens electrolyser. And they've got the other projects which I've mentioned, so Hype Murray Valley and Hype Gladstone. Hype Murray Valley is Albury Wodonga. Both of those projects are ARENA funded. They are going ahead, they are being worked on. So both of those projects are real and will be done. Gemini Western Sydney, we heard that yesterday and we put that electrolyser in place for them. And APA is starting some trials as well. They have a small scale trial that's going on at the moment as well. And that's in the blending area. Green hydrogen for ammonia. So the Yarra project was funded just recently, part of the ARENA one. They've got a 10 megawatt electrolyser going in to produce green hydrogen to form ammonia up at the Yarra project, Yarra facility. Energis project, so we got a government funding to put a 1 megawatt, and we're building it up to 11 megawatts in Victoria, in Dandenong South. And that's the picture on the side of the layout. Air Liquide got funded at the same time we did for a green hydrogen project as well for 1 megawatt. Unofficially, they're hoping to get to 30 megawatts because they've got capability at their site for electricity to do that. They've got a 66 kV line, but officially it's 1 megawatt, so we'll leave it at 1. And their applications are supporting domestic application and transition as well. So what will happen in the government's mind is that they will have Viva doing a project for transport down in Geelong. In the inner west, Air Liquide will have an electrolyser up and running, and they want these up and running by June next year. So it's not so you have to do all the feed, you had to have done the work, and you have to be putting it in place by June next year. And ours will be in the southeast. So you've got the southeast right through, and you can now drive trucks, support uptake of gensets and other applications. And so it's driving those type of things. And then on the other ones, which is the microgrids, and I didn't put your one, sorry, for the blue CRC. I didn't get a chance to add that one. That one is happening as well. Mobility. So Honda, Toyota, Hyundai, Hydronics, Cummins, Ballard, Volvo all have fuel cells in cars and trucks running around the world. More recently, highs on plug power. There was a conversation at one of the breaks yesterday talking about forklifts. Plug Power already have thousands of fuel cell forklifts driving around Amazon and Walmart through the US, and they've got a hydrogen highway fueling those. And so we talk about wanting to do this, it's already happening. Cool. Applications, and I'm going to skip stationary stuff at the moment, but applications, standalone power systems, which I've talked about briefly, telecommunications. Most telecommunications towers either have batteries and or diesel gensets. If they've got batteries, they tend to last up to 6 hours and they run out. And then people have power. So people in Dandenong just recently in Victoria, when the winds came through, knocked down the power lines, power was out for 2 weeks, they had very little telecommunications and no power because it went flat within 6 hours. So there's a push by the federal government to help resilience and make sure that those have longer periods of time. 2 ways of doing it: diesel, which is hard to get in a lot of remote locations and up on hills where you're putting it, or a hydrogen-based system, which is where we're working. Globally, I'm going to run through this really quickly because I've got the 5-minute sign. That went really quick. These are just showing that these are already happening. The commercial train in Germany and the UK have been running for the last 5 years. These should be replacing in 5-year timeframes or 10-year timeframes for ordering trains. We should be ordering, instead of diesel trains all around Australia, we should be ordering the hydrogen train. Alstom have manufacturing facilities in Ballarat and Victoria. We should be doing this now. Buses and trucks have been running around since 2019. Look at them all. There's hundreds of them. And so I'm glad here the Tasmanian government are going to try to do that. The Perth one did a trial 10 years ago, Evan. And the only reason that trial stopped and didn't work was access to green hydrogen. Economical green hydrogen. Energy's examples. So thanks to Gemini, you saw yesterday our little logo was on the Gemini one. We imported and installed that system. So we've cut our stiff. We know all the rules about installing these systems. Toyota, we've installed the genset there to provide power to the innovation centre. Horizon Power, we've got a system there for a standalone power system. Noel, we did the feasibility engineering for a large-scale 90-tonne-a-day hydrogen plant feeding 20% of their ammonia production. And we've got other national and international clients that we're not allowed to talk about because they're real. Future, and I'll wrap this up really quickly. We've got some real advantages in Australia to start leading and demonstrating the world why we should be doing this and enabling technologies in Australia to actually be developed. Otherwise, we'll just be an importer and there won't be benefits to the local communities. Standalone power systems, we mentioned that a couple of times now. There's 22,000 of these around Australia. That's a lot of numbers. Currently, all of them running on diesel. Off-grid excess power. Try to do what Canada's doing and getting some money to put electrolyzers in to get grid stability, but produce hydrogen cheaply to go back into gas lines so it is affordable for the gas companies to do it. Final thoughts, because I know you've got to give me a 2-minute thing right now, and I need some questions. There's several large projects, and we heard about a number of them yesterday in Tasmania. Very few, if any, will reach financial close. I don't mean to be glum about that, but I've seen this for the last 10 years, and large companies go, let's do something. And they say, oh, we'll do a small trial. Oh, that's not economic. Well, we need to do something big because that's economic. Oh, we don't have the off-takers. Let's do something small. And they go in this circle because of corporate structures and other criteria that they need to meet than actually just doing stuff. Whereas Saudi Arabia is building a 900 megawatt solar farm right now and a 200 megawatt electrolyzer to produce hydrogen there. Oman's doing something similar. Spain's doing something similar. So it is a global race, and they've got billions of dollars of government support to get it done, with local community help and support to get it done. How do we drive adoption in Tasmania? So I'm going to reel it right back to what do we do to help Tasmania right now? We're at the Tasmanian Hydrogen Forum. There's large-scale 3 Bell projects that we talked about yesterday. How many of them will actually happen? And what is the realistic time frame? You know, we are putting a system in Victoria. We have to have that up and running in 12 to 14 months. The Blue CRC are putting one in into Tasmania. That was hopefully to be 12, 14 months, probably about 18 months by the time you've got it across the line, just due to closures and everything else and COVID. But they can happen quicker. We can do the 1 to 6 to 10 to 20 megawatts in that time frame. And you think of the volumes that would do, that would allow remote power tourism economics. So if you look at what Tasmania's got the attractions of, tourism, Cradle Mountain, Fraser National Park, most of those run on diesel backups. Why aren't they running on hydrogen systems? We can design systems now, solar, well, not necessarily, but in Northern Territory, we've designed systems that are solar, battery, electrolyzers, fuel cells, that we're now down into the high 20 cents per kilowatt over life of project. And that compares to a diesel solar battery system, which are down in 29 to 30 cents a kilowatt hour over the life of it. And that's assuming that diesel doesn't go up or gets harder to get. So we can do some of these things right now. And the other one was what they're starting to do, which is phase out diesel in transport. Because of the size of the state, you've got the advantage of not having to put in too many hydrogen refueling stations straight away to enable that adoption. And I'll leave you on those ones and hopefully let you ask lots of questions.
Well, thank you very much, Noel. And I get the feeling you grew from 12 to 35 employees in a year and a half. But you might be continuing that trajectory if a lot of these projects...
we expect to be probably 50 plus by the end of this year, and 80 plus by the end of the following year.
All right, great. Well, we do have almost 10 minutes for questions. And I have one on the screen, but I guess I'd like to invite people to show hands. It's a pretty small group, and I'll just go through this one on the screen first, and then I'll come across. So Noel, I'm not sure who this is from, but why are electrolyzers sensible for network services compared to batteries?
They're not in all cases. And so one of the things I started off is there's never a silver bullet to any problem. But in some applications, PEM electrolyzers can go from standby to full 100% load and back down to standby almost instantaneously. And so if you want to manage what is a problem all around Australia at the moment with the uptake of solars on roof, and having basic inertia within your system, which is an electrical engineering problem, the way we set up the grid, we want inertia. Coal plants, other plants run more economically, they run better if you keep them constant. They're not designed to go from 60% load down to 20% load and back up to 60% load when there's solar going in and out of the system. You can, however, have an electrolyzer going up and down, but you're producing hydrogen and you're putting it back to the gas line or for applications, transport or other problems. When a battery does it, you can only do it for a certain period of time. And so the example I like to give is the South Australian battery. It's 100 megawatt, 106 megawatt hour batteries. So it can take up to 100 megawatts, but once it's taken it, it can't take any more. It's full. You need to discharge it. And so for grid firming, which is taking and giving back and working with that, batteries work really well for 1 to 2 hours. If you need to go another 100 megawatts, you need another whole set of batteries. And that's another, in this case, was $90 million to do it. If you want to do 3 hours, you need another $90 million. If you want to do 4 hours, it's another $90 million. We could put a hydrogen-based system in and do all that for probably 2.5 times the cost now. When I first looked at it, it was 3 times the cost. And so there is a balance of why you'd use a battery or why you'd use an electrolyzer. If you're close to a hydrogen line or a gas line and you want to start decarbonising the gas, electrolyzer might be the right way to go.
Okay, I'll give you first, Michael, then.
Yeah, okay. First of all, thank you for your frank presentation. I really liked it. Idea of this workshop actually to identify problems and discuss problems and potential solutions. This is what we have now. So I have one question, simple one. Could you point out the most important or the most challenging thing which you need to overcome as a relatively small company to deal with hydrogen? How to push it forward?
Yeah, no, that's a good question. The biggest difficulty, I think, for all companies, and there is a lot of goodwill in the community within the energy companies to want to start to change. It's the initial capital outlay of hydrogen-based systems versus a diesel-based system or a gas-based system. So diesel and gas systems, to buy a gas genset or a diesel genset or a diesel engine isn't that expensive. It's a 100-year-old technology. It's been refined. It's made in mass production. But then you've got large operating costs and maintenance costs for diesel gensets. You've got a large and going up bill for diesel to be paid. And so I filled my Prado, and it cost me $270 to fill it in Melbourne last week because it's up around $2.50 a litre for diesel now. Hydrogen-based systems, you're paying your fuel up front. And so you have to look at it as an operational life. So one of the things that's not talked about is what might help from governments. And this is a Noel Dunlop personal view, not a Energist point of view or anybody else's. And I've worked in government, so I know how they sort of work. Is can they help underwrite the financial upfront cost in terms of making that viable? Because, as I said, I can get 27 cents a kilowatt hours over a 15-year life of a project, and it was a mine site. And the diesel was equivalent, it came in about 28 cents. But the cost up front was $220 million, whereas a diesel up front was only about 30. And so you got a large difference in that 30, and it's the sticker shock that give people the problems. And then they go, oh, sticker shock, oh, if I pay the $220 million, what if the technology doesn't work? Hey, Helen, we got the man to the moon in 1960. We're not talking about new technology. That's what really frustrates me about the hydrogen world at the moment. The stuff's been around a long, long time. It hasn't been mass produced. That's the hurdle that they need to start driving down. But even you heard Gemina the other week, yesterday, since we put that electrolyzer in, prices have come down 65%. 65% in 3 years. It is going down. And they said the same thing about solar. When you put $10,000 towards the first 1 kilowatt of solar cells, now you get 10 kilowatts for that. So it will happen, but we need to get over the sticker shock and think that this uses new technology. It's not new technology. It's about actually taking the reins and saying we will lead and we will support the local technology. And there is some really, really good research coming out of universities in Australia, out of the Blue CRC, out of Monash University, out of Newcastle Wollongong University, out of electrochemical centres. It goes overseas because there's billions of dollars being thrown at it. It annoys me.
Thanks, Noel. Great presentation. My question is around what you're doing with the fuel cell and your green hydrogen supply and your view on local content and how other, I guess, some of your supply chain or collaborators contribute and your view on where that can go.
Yeah, so we build fuel cell gensets. We build them from 5 kilowatts to 40 kilowatts. Standalone gensets, we build powerhouses, and they're 100 kilowatts to multi-megawatts. And we've got a megawatt system going overseas to service a customer over there. And we've got test beds. But to build that in Australia, we've got the sheet metal being made by 5-axis cutting machines in Gippsland. We've got a whole range of supply chains locally that are helping build that, similar to what happened in the car industry. We have design and we assemble and we manufacture. But we have a whole host of people that support that manufacturing that have been historically supporting auto and other type of applications. And I did see when auto left Australia, 10, 12 of my colleagues who were startup companies left because they didn't have the infrastructure to help support them anymore. So it's not just about hydrogen, it's about what we can do to the whole community to support that. And as I said, we've grown from 12 to 35 jobs. We want to go to 50, we want to get to 80. We want to encourage local manufacturing and the support to it. One of the barriers is getting them adopted, and 2, providing the green hydrogen. So we're doing it ourselves as well now. And we want to do that in Tassie, by the way, as well, if we can.
I've got time for one more question, but the answer's going to have to be like a tweet.
Sure. Okay. Yeah.
Kim.
Thank you. So my question's a little bit different, and thanks very much for your presentation, Noel. So what lessons have you taken for how best to engage with the community on your projects? You'd like to share with us?
Yeah, I think all the people that we currently employ and that we've worked with are really excited by trying to decarbonise. You go and talk to the schools, to the university students, to the general populace, they know we need to change. I don't think it's an issue about that. I think the issue is what we used to early on in the hydrogen industry say the 3 H's, which was the Hindenburg, Hollywood and H-bomb, which are all mythical, very mythical. And hydrogen is actually a safer gas than natural gas. And people have natural gas in barbecue bottles all around Australia, stored probably incorrectly, not connected properly to gas barbecues, and they blow up occasionally. Hydrogen's far safer. If you don't connect the hydrogen bottle very well, it's gone within about 30 seconds and you've got no hydrogen. Bad luck. You should have connected it properly and checked with a soap bottle and you wouldn't have lost your hydrogen. But it's not going to stay around the bottom of the barbecue and then get ignited when you light the barbecue. So I think we think the biggest one is to get and that's happening, and that's why I've always supported Toyota and Hyundai in Australia and was an early member of the Hydrogen Mobility, which is now the Hydrogen Council, was because I think that helps the general populace. If you're driving around a car that's hydrogen, they get more at ease with it. They don't worry about the safety. You know, they think Toyota's done it, it must be safe. And so that will help the adoption into gensets and other applications. And so I'm a firm believer in people want to change, they want to make the world better. We know we need to change. Even the federal government's now getting on board that sort of philosophy in some way. So I think, yeah, the biggest thing is actually overcoming the misconception of that it's not safe.